Okay, for this next problem, we'll be doing something more complicated. The first thing we're going to look at is what we're given. So, first of all, we're given a mass. The second thing we're told is that we're starting with ice, and it's at 0 degrees Celsius, and it's being changed into 100-degree steam. So, let's draw a picture to help us understand this problem. I'm going to start with 0 degrees Celsius ice. And we know at the very end, we're going to end up with 100 degrees Celsius steam. Now, this doesn't happen all at once. So what's going to have to happen in between is that the ice has to melt. And so during melting, the temperature actually stays the same, but it changes into a liquid. And so in this first stage here, it becomes a liquid. The second thing that happens is that the liquid water doesn't automatically turn into steam. It actually has to get hot. And so in the second phase, we get 100 degrees Celsius liquid, and this takes energy in order to change cold water into hot water. The last step is to change this hot liquid into steam, and that's another phase change. So I'll call this Q1. The second phase, I'll call it Q2, and the third one I'll call Q3. So for Q1, we see an ice to liquid phase change. The equation we'll use here is m times delta H fusion. And let's go ahead and take a look at the second stage. For the second one, we're changing a liquid into a hotter liquid. And this is considered a no phase change. If we look on the back of the periodic table, we can see that for a no phase change, we will be using this equation here. So let's go ahead and set that up. Q2 is mc delta T, and for the third one, we're changing from liquid to a steam, and this is a phase change, and we'll use m times delta H vaporization. We're going to plug in some values now so that we can solve this. Q1 is going to be 10 grams times 80 calories per gram. Now, where did this 80 calories per gram come from? If you take a look at delta H fusion and look on the back of the periodic table, it actually tells us that delta H fusion is given to us in calories and in joules. And we're asked specifically to solve in calories, so we're going to go ahead and use this value. If we multiply 10 times 80, we get 800. Grams will cancel, and we're left with 800 calories. We'll do the same thing with the second one, Q2. The mass remains the same, 10 grams. We're going to use the specific heat of water. Okay, looking at the specific heat of water, we're given that the specific heat of water is 1 calorie per gram degree Celsius. So place that right here. And what is the delta T? We're changing temperature from 0 degrees to 100 degrees, and so that's an increase of 100 degrees Celsius, so a positive 100 degrees Celsius. We'll cancel our units. Grams and degrees Celsius will cancel. And so when we solve this, we get 10 times 1 times 100, which is equal to 1,000 calories. This is my Q2. The third one, we'll use the same mass, 10 grams, and we'll need to multiply by delta H vape. So if we look over here, we can see that we're going to use the calorie version, and it's 540 calories per gram. Grams cancels in this case. 10 times 540 is 5,400 calories. And this is my Q3. The final thing we're going to do is to find Q total. We need to add up all of the components, Q1 plus Q2 plus Q3. So that's going to be equal to 800 plus 1,000 plus 5,400 calories. Our final answer, I'll go ahead right at the very top. Q total is going to be equal to, let's do this real fast, 5,400 plus 1,000 plus 800. Carry that one, and I get 7,200